Every structure we build exists under a state of relentless pressure. Mass and gravity are always pulling inward, seeking the path of least resistance. Without a specific mechanism to distribute this load, skyscrapers would sink into the soil, data systems would fragment, and the Earth's crust would yield to internal heat. Across planetary geology, architectural engineering, and high-speed computing, these disparate systems share a recurring structural strategy. It is a discrete unit of organization used to interrupt force and redirect it. It is known as the slab. Understanding the slab reveals how complex systems endure immense weight by turning a point of failure into a surface of distribution. Deep below the ocean floor, the Earth's lithosphere is continuously dragged into the mantle. This is the planetary slab, a tectonic plate subducting into the crust. Intense thermal updrafts push upward from the core, clashing with the rigid downward kinetic force of the subducting plate. As the plate descends, rapid detachment begins. The rock experiences grain damage, microscopic fractures that catch stress vectors and disperse energy outward, preventing total structural failure. We replicate this stress management in human engineering. A deep foundation excavation transfers the extreme weight of a modern skyscraper down into the soil. Within the structure, engineers employ the two-way flat plate. Supported directly by columns, it distributes gravity horizontally across a uniform thickness, functioning like a perfectly balanced dinner plate. But the engineering requirement changes when a space needs to span 40 feet without intermediate support, or when the client wants the structure itself to serve as a design feature. This is the waffle slab. It is the structural solution for grand civic spaces like museum galleries and airport terminals. To build this, workers use complex formwork to create a grid of deep, recessed squares. This geometry maintains high structural integrity while reducing weight. Architectural slabs translate crushing vertical gravity into horizontal distribution, allowing human structures to ascend while maintaining large open interior voids. This principle of grounding weight even exists in the ink of a museum plaque. These vintage wooden blocks are for a slab serif typeface. The thick, block-like structural serifs at the base of each letter anchor the reader's eye. This visual grounding reduces cognitive fatigue by providing a clear, heavy horizontal path for the eye to follow. But as we move into digital workspaces, information overload creates a different kind of pressure. Fragmented data from various integrations creates a disorganized environment where knowledge is easily lost. Slab software addresses this by creating a structural foundation for company data. The system organizes disparate company insights into topics. By pulling answers for integrated tools into one place, it provides a centralized context. When information lacks a clear categorization system, institutional memory fragments, making the most relevant data inaccessible. At the very level of bare metal silicon, digital memory processing is a rapid-fire flow of highly erratic requests. To manage this, the Linux kernel utilizes the SLUB allocator. In computing, rapid processing often leads to memory fragmentation, unusable, jagged gaps in the system memory where data objects don't fit perfectly together. The SLUB mechanism solves this through pre-allocation. It creates uniform blocks, digital slabs, sized perfectly for specific data objects, catching the erratic stream into a predictable grid. This allows the system to process massive information at high speed without calculating new memory spaces for every request. The Linux kernel adopts the name Slab because it uses the same structural strategy as engineering, utilizing discrete, uniform units to prevent a breakdown of the overall system. Pulling back, from the pre-allocated SLUB memory, to the organizational wiki, to the architectural waffle slab, to the Earth's tectonic plates. These systems all rely on a shared engineering principle. The slab is a method of discretization, taking an overwhelming, erratic pressure and containing it within a uniform structure. By replicating this structural law, we can build digital and physical environments that prevent fragmentation and sustain the weight of their own complexity. We see the structures above, but the stability of everything we build depends on the integrity of the slab beneath.